I welcome Dheeraj Anikar for this podcast where he's an expert in expertrons and also an associate software engineer at Bosch now. So now there is a lot of things where you are supposed to learn when you are being in your undergrad, but you will never have that mindset to even learn because you will be filled with your assignments, tests, viva, quizzes. हर
True.
semester में कितने कितने exams आते हैं. Lot
Yeah,
of exams,
absolutely.
lot of things. But
Yeah.
now I'm here to just I'm here having my guest Dheeraj Anikar discussing about what technology means to him all about because he has interned in Cadence also, and I'm here to take his views on what industry is in India today. And also, I think this podcast might give you that one insight where you really wanted to know about what engineering technology was all about in those days and also in the present experience of what he has today. And I welcome Dheeraj Nikar for this podcast.
Thank you, Vishwas, for that wonderful introduction. I'm very happy to be in this podcast with you. I'm willing to share whatever knowledge I have, whatever limited knowledge I have, to help people out there who will be listening to this podcast in the future.
Yeah, Dheeraj, let's start with the questions. No, you have been interning in Cadence for now, and you're
Yeah,
also being a mentor.
yeah,
You have seen a lot of flow in which the technology has been. As
yeah,
soon as the TensorFlow was open source, everything was a change.
yeah.
Uh,
It was.
People were using people were using lot and lot of other frameworks. People were actually hard coding the neural network, but
Yeah,
TensorFlow changed the game.
true.
I just want to ask you this one question of what is technology all about to you?
Okay.
Because you have
Look,
worked on lot and lot of aspects now.
yeah.
So I just want that one view on what technology is all about.
I look at it from two perspectives. A technology by itself, from an engineer's perspective, it's all about using the skills, the methodologies, and science to achieve a solution to a problem. That's what engineers are all about, right? We have to solve a problem which is out there. It might be directly impacting the society, it might be for a particular section of society, and it might be for engineers themselves, right? New software coming up, a lot of software development happening, hardware, whatnot. Another perspective I look at the end, technology is all about helping the society. In it might be directly or indirectly, as I said before. It's all about making the society at a better place. If not for technology, we wouldn't be having the smartphones. People would not be enjoying the life they have right now. People would not be enjoying the movies that they watch on Netflix, on Amazon Prime. People would not be able to game those like high graphics game on their laptop with 32 gigs of RAM. It's technology is all about that, making society a better place and an easier place. If I have to put in that perspective, easier place. It was hard back then, right? Even 10, 15 years ago, there was no smartphones in India, as far as I remember. 15 years ago, if I have to be more precise, 15, 20 years ago. And there was no Facebook. I remember the first social media platform that came was Orkut. I mean, we have come a long way from Orkut. We have Facebook, and now Facebook is for like the older guys, and now we have Instagram and so on and so forth. It's all
Nobody is in
it's amazing.
Instagram. Nobody is in Facebook today.
Nobody's in Facebook today. It's all 30 plus people, as many people say. It's for the 30 plus older people. And look at Instagram, how it's flooded with all the teenagers and many other social media platforms coming up. It basically connecting people and also making life easier for people. And also in actually the main purpose of technology is making or helping the society in many ways as much as possible in all sectors of society. That's what technology is according to me.
Yeah, we connected in LinkedIn.
Yeah.
Thanks to Shavarish.
Yeah.
Thanks to Shavarish for
Yeah.
this opportunity of connecting us together.
Yeah.
Yes, you are true. Connecting people is what, but there are a lot of flaws in that also.
Yeah.
Security issues come in, and also there is problem in machine learning which is involved in decision making in those platforms
True.
also.
Yeah.
There are a lot, but like when I think of this something called as an problem statements, there are some canonical problem statements which are
Yeah.
not being addressed even today.
Yeah.
What are those according to you? No, to me it's like medical domain has lot and lot of problem statements. Automobiles has lot and lot of problem statements.
True.
Space has lot and lot of problem statements. But when it
Absolutely.
comes to
Yeah.
that canonical problem statement where nobody has touched it, what are all those? According to you, know, your views matter to me because every engineer has its own thoughts process. Thus, I want your
Yeah.
views on that.
I think the canonical problems that you're facing in industry also depends on the kind of industry we're talking about, right? There are various sectors of industry. You have hardware, you have software, you have automotive, as I said, space industry, you have manufacturing industry, which is again a huge industry of its own. So each industry has its own set of problems that are, need to be addressed. I'll just be talking about the industry that I have a certain knowledge about. I- Yeah. So regarding the hardware, I think VLSI has come a long way since 1950s, starting from the invention of diode, and today we are talking about 5 nanometer, sub 5 nanometer technologies, and
Even three
Moore's law is
nanometers in the market
even three
almost.
nanometers coming. Yeah, we've almost reached there as well. Moore's law has almost come to an end. We need to accept that we are almost at the fag end. Probably 2 nanometer is something that we might be reaching. I don't think we can go further beyond that because the limitations put up by the quantum physics, the nature itself, we can't do anything because of that. It's not something that we can undo, or we can't go further beyond that. But there are other areas also in the VLSI industry which I think requires a lot of push, because for all these years we have been happy with silicon. All the investments have been going into the design methodologies, how you're using the silicon material. There was research going on to the graphene and also gallium arsenide based semiconductors, but also, you do not have much abundance of these materials as much as you have silicon. Silicon is one of the most abundant materials in earth, and I think there will be more push in those areas like gallium arsenide. We already have semiconductors devices or all of those things from gallium arsenide because they're very very fast. But I think right now we might see a push into, I mean, a lot of investment into making more and more gallium arsenide based design based processors and so on and so forth, and also graphene. We already seen a lot of research going on there in material science. Let's see what happens there. Graphene is very exciting to see all the research happening there. The carbon nanotubes and so much things happening there, right? So graphene and gallium arsenide and various things. I will be talking about VLSI in future. I think we'll be talking about discussing about that. Let's reserve all of the things about VLSI there. And also there are things. I think one of the main things about industry problem is not the technology. I think is about office spaces. Do you really need to spend a lot of money into office spaces because they're not cheap? The rent they pay is not cheap. We have seen in the past year 2020, which basically has been work from home for the whole year, that companies are doing pretty well, right? Some companies, probably the automotive sector where you need to work hands on the hardware, might have been affected. I mean, Bosch, I know the problems that goes with work from home. But if you're talking about mostly the software industry, which is dominating the whole world, it has shown, the companies have shown that their performance is actually, in some cases, their productivity has increased because of the work from home. I think one thing that companies might be looking into the future is, do they really need to invest a lot into office spaces? If people are able to do their jobs at home and also give the same amount of output, I think companies might be going into work from home, like 70-30 split, 70% work from home, 30% in office. I think that is going to be a permanent fixture, irrespective of a pandemic or not. I think that is going to be the future for working. And also, there are other things. For example, hiring. With this age of connectivity and seamless transition, you can talk to a person in the United States almost without any delay. Do you really need to hire from the local area? the the talent pool is available to you. LinkedIn, people across the world apply for jobs. As of now, I told you about work from home, so you really need not be there in the office. So do you really need to restrict yourself to that particular country or that particular area? Obviously the company in the end wants its products to be good, it wants its productivity to increase, so it wants best of the best. So they can just hire people from across the world, and I think that is going to be the future going on. We already see many remote work options available. companies posting from United States that we have jobs open, people across the world can apply. So I think we're going to see that more and more. Your company might be elsewhere, you might be working from elsewhere, and you're getting paid. I think that is going to happen in the future. That also means placements are not going to be as easy in the future. You might not be getting those many jobs. Before, it usually companies used to hire from that locality, but right now it's just open. Everything is open. You need not restrict yourself. I think we're going to see a lot of that as well.
Yeah,
That one thing I really am looking forward to. How is that going to be transitioned from the current working thing we have?
yeah, that's why I got you as a guest, bro. Once you told Cadence offered me a job, but I never got a chance for learning what I was, right? That
Yeah,
actually triggered me. Okay, I should do a podcast with you.
yeah,
That's the thing. There's a lot of things where the computer architecture has actually blown its uh, actual potential to the extreme. That's
yeah,
what it is. You talked about the material science. Materials are getting heated up.
yeah,
The way in which the leakage problems were there in different technologies has still been experienced, but math is getting different. Math
yeah,
behind every technology is something different. If you take FinFETs, FD sois, there are other materials which are just coming. you know Math behind it literally makes a lot of difference. But what's inside a computer architecture, according to you, was it different from 2004 and now? Because we all had this access to some Celeron or Intel
true,
Pentium computers
true.
for sure.
Something, yeah,
We all
for sure,
had
yeah,
that access, but like, what's that
true.
difference that you find today?
Today, so current computer architecture is basically the whole system itself with various functions, various uh, the processors, you have the memory, everything makes up the computer architecture together. When you talk about how has computer architecture changed from 2004, when I was having a desktop with Intel Pentium, as you said, and to today's age, I think one of the most important thing that we can see the change is the parallel processors. I mean to say multi-processor devices. We started off from dual core. Now we have quad core. We have phones with octa core, and we're talking about 16 core processors in the future. I mean, parallel processing is one of the things that has taken up quite fastly, quite swiftly, because as I said before, the amount of transistors on a chip, that is VLSI basically, that was increasing, and hence the processor used to get faster. But after the limitations came there, we needed to look at different ways of making computing faster. That's how we came across parallel computing, which was there before. It is not very new field. It was already there before, but with the advent of these technologies, which allowed us to enable this parallel computing to come into realization. Parallel computing has taken off like a rocket now. Uh, I mean, you're talking about superscalar computers now. You're talking about pipelining. We have so many things which makes computing. I mean, you have been experienced in various deep learning and training your algorithm. You have experienced your
Data
computer.
science
I think
pipelines and the computer vision pipelines, they actually matter a lot these
they
days,
matter a lot. Yeah,
reducing the complexities. Yeah.
yeah. They're using the complexity and parallelizing. Even I did my final year project, and one of the ways I went about speeding up was parallelizing is very important. We've seen many companies investing a lot in GPUs as well right now. GPUs is, I mean, not only just not for gaming, for various things GPUs are going to help. Again, coming back to your it's people who have worked with ML and DL and trained in their own computer would know how GPU is going to help in their training. So we have seen how helpful it is. And yeah, it's just taken up a lot. It's totally different from 2004, obviously. As I said, parallel computing and just so many advancements going on.
Whether you have 32 gigs of RAM or 128 gigs of RAM, compute is not enough today.
Yeah,
Because that's the amount of sturdy nature that the data set has got over the problem statements.
true.
But you know in embedded, right, in VLSI embedded, there are not such great problem statements which requires too much compute. There is a
Yeah,
requirement of compute, but there is nothing called as a great requirement of compute required,
true.
because everything can be gone through with some pen and paper, because that's how that industry came up with.
Yeah.
Never they had the CAD tools, but they started fabricating,
True.
Jack and Kilby gave the JK flip flop and
Yeah.
everything. Such histories have come out. Bell
Yeah.
Labs, AT&T have marked the history of what technology was all about.
Yeah.
But what was that situation when there was no TensorFlow at all? Probably, probably you should have had experienced that, because I think probably you were in class 12, passed out and everything,
Yeah.
kind of like that. But like, what was that actual thing when there was nothing called as TensorFlow? Have you ever heard of what they used to do when there was nothing called as TensorFlow available open source?
I came across TensorFlow during my second year of engineering, and I've interacted with some seniors who have been in this machine learning area and working on that. They told how they had to use their own computers to train their problems, and also, as you said before, building neural networks by from scratch,
Okay.
right?
No,
With
hard
all of
coding it.
the hard coding it, it's tough. It's tough. I mean, you need to train, and you're not sure whether the amount of layers you have in your neural network is enough for your particular problem that you're going to solve, right? And with the TensorFlow and, as I said, various other packages out there, the neural networks are, and they're coming in hand, and you can use them to solve many problems without having to worry about building a neural network from scratch. All you have to worry about is how much you need to train, and optimizing, tweaking the neural networks a bit for the particular application that you are dealing with. And also, again, transfer learning is pretty easy in the sense that you just need to change the data set that for which the neural network is trained. So that has become so easier. I can't imagine the plight of people before, how they had to build the neural networks from scratch. We have to thank them a lot for the SSTs, for the mobile net, and all of that, because it has helped us a lot, right? For doing our projects, we have started off with that transfer learning, right? Building an ML or computer vision based project. We started off with that. We did not worry about building a neural network. We just use the existing neural network, train it for the data set we have, and then just go about solving a problem. Yeah, that's how it is right now. It's gone a long way. It's come a long way.
Yeah, when you told about that, yes, there were places where there was nothing called as TensorFlow, because early researchers never had something called as
Yeah.
TensorFlow. Even when you see Yanli Khan's video, recently I posted it on the LinkedIn. You know, it was just a DOS OS which had nothing, but it was like an kind of an gaming, the gaming console which we used to hold in the
Yeah.
hand and everything. But I always wanted to ask you this one question, where now you have worked in a lot of problem statements in computer vision, deep learning,
Yeah.
and all. But like, which is the technology which told that this is the most fascinating thing that I've heard in my life?
I'm going to tell this, but many people are going to think, yeah, it's the hype around it. But I'm really, really fascinated by artificial intelligence. It's not because of the hype. It's not because many people are talking about it. It's because I find it fascinating. Yes, AI has been mostly a pattern recognition based system rather than having an intelligence of its own. It's mostly recognizing patterns, but the potential it has in the future, with a lot of research going on about artificial general intelligence, AGI systems, and other things, I think AI is very fascinating. I've worked on projects on machine learning. I've not worked with an AI based system, but I've worked projects on machine learning and data science, and I uh, to get just about itself, just talk about pattern recognition or data science, finding patterns in data and getting results out of that. That itself, you and I cannot do that. The amount of data we have today, it's unfathomable. I mean, it's not even terabyte is small. You're talking about hundreds of terabytes, thousands of terabytes, and dealing with
Zettabytes
those
of
data.
data.
Yeah, basically that, and dealing with that data, that amount of data, and finding out patterns which will help you in making business decisions. I think many companies would have saved a lot of money, which would have either gone to waste by making right decisions at the right time by analyzing data. You talk about the sports industry, how much analytics has come into that and has helped teams make right decisions into which player to buy, how to spend their money, so on and so forth. That itself is a huge industry, right? So the data, I mean, after the age of data, I think machine learning and data science especially has come up a long way, and people are using it almost all facets, as I told, sports, be it technology, so much. And it's just fascinating that it's just basically in basic level, it's just math, right? Math has always been existing, statistics has always been there. I think data science is is kind of a fancy word for applied statistics in a sense. I'm not going, it's not an offense to data science people. It's like it's basically applied statistics. You're using programming tools, statistical tools, to make what the decisions, and make the data visualization, so much things you can do there. But finding out patterns is very, it's a fun thing to do as well. According to me, it's very fun to find out patterns, to see, oh my god, how I didn't even think that this would be affecting my business in such a way. That's the kind of reaction I think people would be having after seeing, what data can tell you. Even in sports, many cases would be there, I'm sure. I think people who have watched the movie Moneyball would be relating to, would be understanding what I'm trying to say. It's a really fascinating thing. And AI, AGI, I'm I'm really fascinated to see how the world moves in the future. I think that is going to be the future. Also, research happening in quantum computing. I think that's also one of the things that we are going to talk about in the 22nd century. In the 22nd century, we'll be talking about how quantum computing developed in the 21st century. I think it's going to be amazing for the next 60 years, 80 years, sorry, how these two technologies go on developing. I think it's very, very beautiful to see. Yeah.
Yeah, I know. It will be an history one day. Whatever
Yeah.
the work we do will just be an history one day. But because techniques are evolving,
Yeah.
inch by inch with a new solution, step by step, it's a whole new transformation. We used to
Absolutely.
think of mobile nets as just being just coded from one framework, but there is a framework for it, TF-Lite, TinyML,
Yeah.
lot of things. Edge Impulse is also there. The
True.
company which is giving out lot and lot of edge devices also. A lot of things. But like when you told me about the statistics, right? I was almost, it's like I think I framed this question back just for you.
Okay.
You actually came in the order and everything was fine. I just want to ask you this one question of what is statistics all about to you? Like you have worked on embedded, you have worked on data science, computer vision. You know,
Yeah.
there are techniques which have influenced it and you have coded it in the form of an algorithm, but everything that our task is being done by the matrix multiplication. Everything
True.
is matrix multiplication at the end of the day.
Linear
The one
algebra.
say,
Yeah.
yeah, the same linear algebra. What is statistics all about at the end of the day when you're worked in different fields now?
So, in the most boring sense, I can tell statistics is collecting and tabulating data. That's all I can say. That is what statistics is, right? People have been starting from medieval age. People started counting is the basic. Without counting, we wouldn't have come across statistics. Then we came across how many crops do we have, how many uh, animals do we have. That is again kind of statistics, keeping track of how much things we have, how much things do not have. And then came across economics. I think economics, money has been very influential in the field of statistics. How can I make sure that my capital increases, how do I need to spend my money, and a lot of research going on. Many economists have been great mathematicians as well, and they have come across beautiful research papers which has influenced the area of statistics and mathematics in a huge way. Economists, I'm talking about economists. So I think economics, we have to thank economics a lot for the developments that we have come across in the area of statistics and mathematics. Again, when you talked about the applications, right, in technology's perspective, it's applied statistics in a way that you're using the stats for, as I said before, you're talking about business analytics. It's about making business decisions, so getting insights. So it's not only, so statisticians will just collect and tabulate data, but at the end, you talk when you have to make decisions or whatever domain you're talking about. It's about, you need to have the domain knowledge as well. You need to have knowledge of statistics, and you should know how to make use of statistics and have a lot of common sense as well. I think people uh, for example, I'll give you an example. I want to talk about this example. I've been going through a course and one professor talked about it. um, how mobile banking affects the profitability of a bank or a company. So when you do data analysis, some people came across that mobile bank mobile that was the thing they came across in the end. Mobile banking affects the profitability, but that's not it, right? Many people, older people, are not willing to use mobile banking. When I say mobile banking, I'm talking about smartphones, using smartphones to do banking. Older people do not like it because they're not willing to use the phone with the smaller keypads to type in the passwords and so on and so forth, because they're not adapted to it very well. They are more willing to use the computers and laptops to do that, right? So the thing is, age has a correlation with productivity. So with age, younger people, I'm not talking productivity in the sense, I'm talking about banks, the profitability, sorry. The profitability is the word that I needed to use. So younger people are willing to use mobile phones to make banking, to do banking things, like taking a loan or transfer of funds and so on and so forth, because younger people are the ones who are more into taking loans or taking money, because that's the age, right? You're talking about 60 people above the age of 60, they are probably retired, they will not be doing a lot of banking. So the thing was, the actual correlation was between age and profitability for the bank, but the result that they gave was the correlation between mobile banking and profitability, which was wrong. That was not the case. What they found out was, after a proper research with a bit of common sense, mobile banking was related to age and the profitability was related to age. In the end, it was not mobile banking which was correlating to the profitability, it was age relating to profitability. Younger people tend to use banking more, younger people tend to use mobile banking more, so the bank's profit is going to go more. But what these guys did was they found out a correlation between mobile banking and profitability, which was a coincidence. That's it. It's a coincidence. So that why I gave this example is because you just put a regression algorithm. Most people would know what a regression is if they've done engineering. They just put a regression algorithm, find that there is a linear relationship y equal to mx plus c. They found that, oh, this is related to that. No, it's not always the case. You need to have a bit of common sense. You need to have a bit of knowledge about the domain you're talking about, or else you're just a basic statistician who's just collecting and tabulating data without knowing the domain knowledge, without knowing what you're actually working on. uh, you're not going to be much helpful to the company. That's what I wanted to make. There's a difference between a normal statistician and a data scientist. Data scientist for a particular domain should have the domain knowledge, or else he should have a person who is going to give him the domain knowledge necessary to work in that particular field.
Yeah, Dheeraj, there is a lot and lot of difference between what statisticians can do and data scientists
Yeah,
can do. Because
yeah,
statisticians can only do the math behind the data, but we are supposed to work on the insights of the data.
yeah.
What does this data say to me? That's
True.
what we actually work on, whether you do data visualization, data analytics, any course,
Yeah,
whether you build it in a dashboard, Tableau, whether you build it in R, anything,
yeah,
because we are born to give an insights. We are not here
yeah,
to do the math behind it. Math, statisticians part, but for us, it's the insight.
yeah.
There has been lot and lot of ways in which problem statements have been approached. Technology has seen lot and lot of ways in which VLSI also has seen lot and lot of ways in which technology got shrink.
True. Yeah,
Softwares are now being in a form where there are lot and lot of APIs which are getting stashed one after the other.
true.
It's just API calls. I always say this: when you want to build an AGI, you are just one API away from your
Yeah,
AGI system, because
true.
Amazon SageMaker is there. Just get the API, but you should know how the data is, right?
Yeah,
It's all
yeah.
just behind the data. But I just want to ask you this one question: what will be the form factor of the technology tomorrow?
I think when you talk about technology, as I said before, various fields have been there are a lot of investments and research going on. As I said, in the VLSI industry, we talked about the graphene, gallium arsenide based semiconductors in the future. We're going to see a lot of there. One field that in particular that I want to talk about is cybersecurity. I think it's going to be relevant, even more relevant now, because when data is the new oil, as people talk about it, companies do not want the data to be leaked. Honestly, I mean, if your data is leaked, if you're the owner of a company and you're working on a new project which might change the face of technology of the future, you do not want that data or information to be out to the public before it is launched, right? And if that goes out to the hands of public or your competitor, you're going to be at loss. You're going to suffer a severe loss. it's not only about if you're going to create a new technology, it's going to change the future. There are a lot of things going on there. Your employee data, so many data are being there. And if that is not secured enough, if they're not secured in the right way, and if it falls in the wrong hands, it's going to be a huge problem. We have already seen so many cyber attacks happening on various companies. I don't know what fund do they get. Obviously the main thing that they're doing it for, because they want money, they're going to hold the company for ransom, and then once they're paid, they're going to give the data back. But if you're not securing your data enough, it's going to be a huge problem. And cybersecurity is going to take, it's already taken off in a huge way, and cybersecurity is only going to get better and better, because we already seen some companies investing in quantum encryption, that's quantum key distribution algorithm based encryption techniques to encrypt the data. And that's how, again, quantum computing comes into picture here, right? Again, computing field has enabled us with this new algorithm, which has enabled us to encrypt our data in a much more stronger way, which is basically almost impossible by a classical computer to decrypt the data. I think more research will be going on into this field in various other techniques, new algorithms, new cryptographic techniques. But quantum computing, I mean, encryption is going to change the facet of cybersecurity, is what I personally feel. We already seen some companies. There is a startup in Bangalore as well, which is working on quantum cryptography, which is actually funded by Cisco. So if it is funded by Cisco, so we already see how much potential it has, and many companies are adopting to this. So cybersecurity is going to take off in a very, very nice way. And and also, note to all the youngsters watching out there, there'll be a lot of jobs in that field. So if you're really looking for jobs, cybersecurity is, if you're interested in that field, cybersecurity is something that you need to keep an eye out for, build the necessary skills, and if you're really skilled enough, you're going to get a job there. Is what I personally feel, because there are abundance of jobs there. And I said before, AGI systems, again, beautiful field. And also, we might be not only answering questions related to technology, we might be also seeing how technology can be used to talk about questions in the field of natural sciences, be it neuroscience, to understand how a brain functions. People are using data science techniques, signal processing techniques, to understand more and more about the functioning of the brain. Exoplanet discoveries. Um, you have deep learning being used now to understand more about the galaxies, the stars. And we already saw the imaging of the first black hole a couple of years ago. The amount of data that was generated and how much they had to work on to finally get that image shows how technology is being so much helpful for people, even in the field of natural sciences. And I think it's a wonderful age to be in. It's a wonderful age to be in. And also, talking about technology, um, imagine 100 years back, when the industry was more of a manufacturing industry, where you had a company with just 10 employees and worth more than $1 billion. I'm talking about Instagram, obviously. With just 12 employees, they sold a company for more than $1 billion. Imagine talking about a company with just 10 employees being sold for $1 billion. You couldn't even think of that probably even 40 years ago. I mean, people with their ideas can do a lot of startups if they have the right idea, and they can work on impacting the society in a very positive way. And people can make a lot of money from that, as I told the Instagram example. So it's a very fun time to be in if you're really passionate about what you do in engineering. If you really want to solve problems, if you're really good at it, you can contribute to society in various sectors. So technology is amazing. I'm really thankful that I was born in this era to see how technology is going through its changes. Quantum computing is still in the nascent stage. Even AGI is still in its nascent stage. I mean, it's a wonderful time to be in.
Thanks to Charles Babbage. We
Thanks
learned
to
a
Charles Babbage.
very we learned about him like a very, very long time ago,
Yeah,
probably when we took our computer science classes. I think probably, for to
fourth,
me,
fifth
my
standard
first
probably.
computers. Yeah, yeah, fourth standard, yes,
Fourth
fourth
standard.
standard.
Yeah,
People have written Charles Babbage. Instead of writing Babbage, they have also written
cabbage.
cabbage,
Yeah,
because teachers taught us like you should understand.
That
Okay, remember him as cabbage and
cabbage, yeah, stuff. Yeah,
a lot of things.
yeah,
A lot of memories. When you were talking, I was getting lot of my fourth standard, fifth standard memories. Because that's how the technology that you and I have seen.
yeah,
Probably if I ask an if I ask a person who is like probably 5 years old now, probably he has all the access to the technology. But since we never had an access to the technology,
yeah,
and later we saw that technology, we are like, okay, this is something else. So this is all the keynote to the people who have been working. It's billions and billions of dollars of research and
yeah,
years of hard work from lot and lot of people that
yeah.
got us here.
And also, you look at IBM releasing their online platform for working of building quantum logic gates. They're making it fun. One more thing about the technologies are, if you want to get youngsters interested in, I mean, and I say youngsters, I'm talking about young kids interested in it, you need to make it fun. And IBM has released a game which works on, solving puzzles, which will make you understand how quantum logic gates work and how quantum systems are built. And they have the open source platform, and all of this, what it does is draw people towards technology, and draw people, make people understand that technology is interesting, it's not boring. Many people think, no, math is boring, math is tough for me to understand. But if you really get the right idea, I think it's going to be fun. You can work on a lot of things, you can work on a lot of problems. There is the applications of technology is just limitless. It's just limitless. It's just unbounded is what I personally feel.
No, Dheeraj, I just wanted to ask you this question. I know it's out of the topic now, but like, do you feel that math was being invented for the morons?
Math was invented for morons. uh,
Because there are a lot of people who make a lot of objections against the technology, but math has really given that answer for everything.
True.
You know, there are scientists who have literally given the insights on how the cancers are being formed
Yeah,
with the mathematical equations.
yeah,
The variation of the hormones also they have given.
yeah.
There are a lot of TED talks on mathematics which I have given. You know, because I know this is off of the topic, but I just wanted to ask you this one question. Do you really think so in that way? Because they saw the problem statement of what morons used to say on what the technology was, so now they invented mathematics.
I don't think so, because math has always been there. The reason why science took off in a way that it has later on, especially we have to thank Newton for coming up with the calculus, in order to understand his passion to understand about how the universe functions. He came up with us calculus. And I think mathematics, I think it's inherently built in this universe. I don't think it is something created by humans. If it was not the case, how would mathematics be so absolute? In the sense, you cannot, if anything is true mathematically, it's you cannot question that, because that's how mathematics is. It's the expression or the language of logic is what I personally feel. And we have just come a long way since 1700s, with a lot of mathematical techniques, a lot of research, a lot of developments in the areas of mathematics. Linear algebra, I think, has changed. As I said, machine learning. If you want to learn machine learning, linear algebra is one of the important things that you need to know. And how calculus and linear algebra is basically, those are the two foundations upon which majority of the technologies are built. When you talk about, even if you talk about VLSI, you talk about devices. If you talk about devices, you want to understand the device physics of that. Talking about device physics, you will be coming across a lot of equations. You'll be a lot of differential equations. You'll be dealing with a lot of quantum physics, obviously, right? So you'll be dealing with differential equations, the Schrodinger's equation, basically. I'm talking about that. You'll be dealing with a lot of calculus. I think mathematics is something, how the nature expresses itself. It's the kind of language it is, and we are just using it. It's what I personally feel. Uh, is that what you expected, or was it a different kind of question you asked?
No, no, it's what I really expected. It's what I
Okay,
really expected from
okay,
you. Yeah, I can get to know the way you solve the problem statement is completely unique according to me,
okay.
because I think I can see that from the way you have been talking with me, I can see that, your approach for the problem statement is something which is unique because I think probably in your age and my age, I think probably we would have never give ourselves the thought of demystifying what is all these technology all about,
Yeah,
right?
yeah.
That's what I just wanted to ask you this one question where what's your approach in solving a problem statement, whether it be in any field?
First thing about problems in trying to solve a problem statement is you really need to understand what you're dealing with, right? People just start solving a problem blindly without even really trying to understand what they're trying to do. Uh, the first important thing is really understand what you're trying to solve. If you do not know what you're trying to solve, you're not going to solve that problem, right? So the first thing is observe and be key. I mean, observe in the sense you really need to open your mind and do not limit yourself, do not keep restrictions, because a problem statement can have variety of approach to solve that problem. You should not think in linear way, in one particular way. So the first thing is really understand the problem, and second thing is read about areas which are related to the problem that you're trying to solve, be it research papers, be it technical papers. I think that's very important. It might not be directly helping you to solve your problem. It might be just one particular technology. It might be on one particular methodology that paper might be talking about. You need to read that. Then you need something else and you read a paper about that. So you just need to equip yourself with knowledge and then start solving the problem. And obviously, your fundamentals must be really, really good. If your fundamentals are not strong enough, whatever problem you're trying to solve in whatever area it is, it's not going you're not going to able to solve it. That one fundament. So the three key things are the fundamentals should be right. You should be willing to learn a lot, read a lot of papers, read a lot of journals, to understand what you're actually dealing with. And also, most important thing is really understand what problem you're trying to solve.
Yeah, that is the key. That
That is
is
the
the
key.
key. You
Yeah,
you don't have any alternatives to it. You need to do your hard work. You need to put in. Even if you're a genius, you need to learn how to code.
yeah,
Even if you can figure out what an algorithm is, you need to learn how to code.
yeah,
Now, I just
absolutely.
wanted to ask you this one question because you have seen how the VLSI technology has grown in a while,
Yeah,
right? From 180 nanometer being the buzzword, today the 7 nanometer
7 nanometer.
GPUs are in the hand.
Yeah,
GPUs are in the hand. Companies are working in even decreasing these form factors of the technology.
true.
What will be the form factor of VLSI technology tomorrow,
uh
according to you?
One, yeah, we've already started off with the hint of what we'll be talking about in the previous questions. First thing, as I said, miniaturization is probably not the future. Probably a few more years of research into that, and we might be hitting a roadblock there. And the next thing is more and more into, we might see more research into the low power designs, which might be, we might see a lot of research going on to that. We already seen many low power designs going on. Many companies are working on that, because the main thing in
FinFETs
VLSI
are
is
on the way of
FinFET.
low
Yeah.
power design.
The most important thing in VLSI is the PPA optimization, power, performance, and area, right? So power, we have seen low performance design, and for performance, we have seen that parallel architectures, the parallel processing, which we are seeing there. And also, you are interested in that area called deep learning hardware. We might be seeing a lot of such things, and we might be seeing also ML based techniques to see whether our circuit is optimized in terms of PPA. We might be seeing a lot of applications of machine learning in this area, or AI in this area, to see how can we make our circuits more optimized in terms of area, in terms of performance, in terms of also, uh, oh, I forgot that. Power, yeah, power, low power, performance, and area. We might be seeing ML being used there. And also, as I said before, research into material science, graphene and gallium arsenide for faster and faster processors. I think that will be quite a long way, because we have not yet, we do not have a lot of design methodologies available for realizing an actual graphene based semiconductor, or gallium arsenide we do have, but there are a lot of limitations there. Silicon is the de facto material that we are using right now because of its abundance and the ease to produce a silicon based processor. And one more thing is, and talking about VLSI industry itself, I wanted, the industry is changing. There are not a lot of jobs, because when you're talking about jobs, compared to the software industry, there are a lot of jobs, because they're not only the big companies, there are also the startups. tell me how many startups you have seen in VLSI. How many startups you have seen in VLSI? There are not a lot,
Probably hundreds, hundreds.
probably hundreds. Why? Because I read an article. Venture capitalists think when you want to start a semiconductor company where you're going to design your own processor and so on and so forth, they think you'll be requiring a minimum of $70 million as an investment, and they expect 10 times the return from the company. So if that is the expectation that we have to meet, or if a person who wants to start a semiconductor startup, if he has to meet that expectation, it's going to be very, very tough. And when I say the jobs are very less, because VLSI rewards people who are really, really skilled, that you're going to get those skills either by getting years of experience, or you're going to do your masters, you're going to upskill yourself, study a lot in that particular area. Unlike software, I'm not demeaning software in any way. Again, you really need a lot of skills to be successful in the software industry, but the amount of jobs you have there, it's pretty easy to get a job in the software industry when you are comparing it to the VLSI industry, because there are not a lot of companies, and secondly, you really need to be skilled in the areas of VLSI if you want to be successful. So the industry is going in that direction.
Yeah, I know, because it's the requirement of the new
It's
era of technology,
Yeah,
because you need to be skilled enough in order to solve the problem statement one after
yeah,
the other. Problem statement will never be a piece of the cake. It will be a lot of
true,
hardships required, which is there. I just wanted to ask you this one question, where there is code and algorithm involved in everything.
true,
Whether it's die placement, it's an algorithm which is working there.
true.
Now reinforcement learning is in the picture for die placement. Now there are a
Yeah,
lot of ways in which AI is actually designing its own system now. You
algorithm. Yeah,
know, even algorithm, yes, AI systems have become that sturdy in which they're thinking of their own algorithms now.
yeah,
Facebook used to shut down its AI research because it was generating its own language and it was
yeah,
communicating and nobody was understanding. That was a meme
yeah.
material for me when I joined the engineering in 2017. That was a meme
Okay,
material. Everybody was
okay,
behind. But like, you know, this present era is behind one thing: money. For that,
true.
they never know how to build themselves. They will never get
Yeah,
to know how to build themselves, because what the thing is, if I know how to code in this language, everything will be fine. If I understand this algorithm, everything will be fine. Which is the
yeah,
most important aspect now? Is it the code or is it an algorithm? Because you have interned in a lot of in a
yeah.
places for a lot of while now, and I just want your insights on this.
So I have to look at two perspectives. If you're looking at the working, algorithm is the most important thing, because you need to get your algorithm right. And also, when you're trying to code anything, the algorithm is the basis for your code, right? So if your again, if you're solving a problem, if you come up with a better algorithm, you're going. That's the important thing. You can code anything. You can, if you have an algorithm, you can code it. That's what it is, right? You code based on an algorithm out there. Algorithm is important if you're trying to solve a problem. So the better your algorithm is, the easier or quicker you're going to solve the problem. From another perspective, why the code is important is because when I worked in a company, and companies really are strict about how we're going to code, because you're going to, in the end, you're going to give it to the customers, and the customers need to understand the code. That's the end point. And if they can't understand the code, if people cannot know how to use the code that you've written, it's not going to be much helpful. So the way you've written the code is also important in that perspective. The way I've written the code, I mean, you should the coding standards, how it is being used in industry. You need to have statements, you need to have strings of explaining what this particular piece of function does, what this particular piece of function does, the kind of variable names you use, and all of that. In that sense, I'm talking about the code. In that sense, your code should be understandable to the people who will be using it in the future. But obviously, the most important thing is the algorithm, because that decides how your code is going to work, how fast your code is going to work. And if you're talking about the memory resources it uses, the hardware resources it uses, your algorithm must be right. If your algorithm in a way uses lesser number of resources because your algorithm is efficient, efficiency is the most important thing, right? The better it is, the faster it is, and hence algorithm is important in order to achieve a solution. uh, Code is for understanding purposes, and the looks, if you understand what I mean.
Aesthetic part of the.
Aesthetic part, yeah.
No, there are a lot of ways in which you have actually cleared a lot and lot of statements,
Yeah.
where whether it's, I've actually skipped a lot of questions now because I'm not ending it. I'm not ending it. Don't worry.
Okay.
It's been a, no, but like I just want to ask you this one question where uh, what are the technical constraints that you faced when you were in the initial days of the projects? Whether it can be in the internship, whether it can be when you're doing one your own DIY project, lot,
Okay.
what were those initial constraints that you faced?
When I went about doing my machine learning project, the important, the most first problem I came across was the data set. I was working on a detection of luggages in an airport, which was left unattended for a long periods of time. So we need to have trained a system or neural network to detect bags from various, sorry, backgrounds. So I didn't have any data set which provided me that. So I needed to go around, travel around Bangalore, traveling to different places, clicking pictures of bags. And not only that, because since your neural network has to differentiate a bag from various kinds of background, I needed to crop the images of bags and put it in various backgrounds and create more data set with the amount of pictures I had and train it. That was a manual process. You really did not enjoy doing the cropping and pasting and doing all of that, but I really did enjoy going around traveling and clicking pictures of bags wherever I found them in various kinds of different backgrounds. So yeah, that in an ML or computer vision project which I was dealing with object detection, I found that problem to be very irritating because it was manual task, and it was really taxing in a way. And other projects, one of the thing was not getting the right resources. For my final year project, we had to, in the end, our main aim was to implement it on an FPGA, but due to the pandemic we didn't get access to hardware later on, and it was really frustrating, and everything had to be done on the computer. We had to use the Xilinx Vivado. I think you would have heard of that, Xilinx Vivado, to simulate that particular thing we are working on. Again, there the first roadblock was the hardware availability. And before that, the problem was we had to make our code more efficient. We needed to have to parallelize our code, and we needed to worry about the kind of FPGA we're targeting on. In the end, if you work with Xilinx Vivado, you know that you're targeting a particular FPGA, and every FPGA has its own number of LUTs, no more its own number of logic blocks. So you need to keep that in mind. You need to keep in mind of the constraints. Hardware people will know that. People who work with hardware will really understand what I'm talking about. The resources are not unlimited. You have to keep in mind what amount of LETs your FPGA provides, and how the memory access is going to be, uh, and the data is coming in through a stream as a stream, and the data is not going to be coming immediately in a hardware. There is going to be certain delay, there's going to be latency, and so much things that we need to worry about. It's just not the software code, it's not just the algorithm. We needed to worry about the hardware limitations as well. That was in a hardware project. That's one of the main limitations that you come across. The resources, how you're going to manage the resources that you have. That was one of the roadblocks that I hit. And other thing was, I did one data science project which was predicting the results of cricket matches, and it was quite a funny one because we didn't initially we were getting prediction rates of 48%, 47%, which is worse than the coin toss. So it was not helpful in any way. But with further tweaking with more data, we were able to get it up to 58, 60%. We did not do any manipulation. We were able to do it right and get more than 58, 60% of accuracy. Again, the problem was getting the data. Again, a lot of manual work because the data is not going to be in the way you want it to be. You needed to, it's data is unstructured. You need to delete the things which you do not want. And we were using logistic regression, so we needed to label them as zeros and ones. So much thing that we needed to manually. Yeah, so it was fun in the end. If now remembering all of that, it seems fun, but while doing it, it felt monotonous and taxing, and because it was a manual thing, right, to do. But remembering now, looking back at all of those things, it was so much fun working with your teammates to do all of that. It was really fun looking back at it now.
Yeah, that's how the data science is all about.
Yeah, yeah,
Even though you get an access to the code somehow or the other, you need to work some taxing off.
yeah,
That's how the hard work pays off at the
yeah,
end of the day. Even whether your data is not that good enough to just see, but there can be a lot of insights in it also.
yeah,
Alan Turing also said
yeah,
the same thing. Whether the model performs with 10% or 20%, just try to use it because it also has something as an insight.
yeah.
But when you talked a lot about hardware, right? I wanted to ask you this question where what's that secret to build a perfect hardware project?
Perfect hardware project.
Because you have worked on a lot of hardware project,
Yeah.
right? So just that one.
So again, hardware, it might be embedded hardware, it might be you're designing a circuit. So many, even hardware, you have various areas, right? It might be a digital design you're going to do, or it might be analog circuit that you're going to build, or it might be an embedded hardware related project that you're going to do. Each one has its own limitations. When you talk about analog or circuit in the basic sense, you need to worry about a lot of things because again, here comes the difference between theory and practical. That's the thing. In hardware, it's going to be so much more evident how your theory knowledge is not going to be as effective here, because we talk about op amps, and we know, we talk about it having an infinity gain and so on and so forth. It's not going to be the case here. And when you're trying to build a circuit, you need to worry about the electromagnetics between, the wires, the affecting, because current passes through. Whenever the current passes through, there's going to be a magnetic field, and you should not be interacting with other
Electromagnetic
devices on.
interferences.
Yeah, electromagnetic interference, that should not be the, you should not allow that. There are a lot of other things to worry about. And as said before in my previous project, when I'm talking about my final year project, we had to deal with the the hardware resources, the limitations there. We could not just code the way we wanted it to. We had to keep the hardware resources in mind, the memory access time, the latency, so much things that come into consideration. uh, it's Once you do the project, you'll understand it, because each hardware project has its own limitations. Depends on the kind of projects you're doing. um, that's that one thing I really need to tell, that because you might be working, I worked on video compression, I worked on implementing video compression on FPGA platform. In the end, I was not able to do it on FPGA because of the non-availability of that, because of COVID thing, we couldn't go out. Many people might have worked on FPGA based CNN. They might, they will be understanding what I'm talking about. It's not easy. Implementing a neural network on a software in terms of code is different than implementing a neural network, designing it on high level in C, so C++, and it converts that C++ into RTL code, and then you need to put it into FPGA. There are a lot of problems that are coming there. Memory utilization, as I said, it's not going to be quick. The data, when you build a neural network here and you use a computer and just you build a CNN and using a project, that's different. And we're implementing an FPGA, the data is not going to be as fast. There is still going to be limitations. There's going to be latency, which people really need to keep in mind before they're going to design that things. I think that they really need to understand.
Yeah, when you told about the RTL, the LUTs,
Yeah,
and lot of things, right? There is software involved somehow or the other.
true.
But like when we come to the actual hardware, right?
Yeah,
When we see the way the hardware has been fabricated, there is an improvement in the performance which the technology has shown. I
yeah.
just wanted to ask you this one question: will VLSI make the technology much faster than we have today? There are ways in which it can be related to more of materials, but architecture has differed, because of Tesla, ampere architecture, and the GPU showed an huge improvement in the performance. That is
Yeah,
in a way which like 2x, 3x kind of a performance leap
yeah,
which we had seen.
yeah.
That's how, what do you feel about this VLSI trend, which can really change the form of technology? Have you come across any of those which can be the new disruption in the VLSI technology?
I have not come across a lot of that. I have not read into those things. But as you said, I have had read an article about that, and it's very really fascinating to see. And one more thing, deep learning hardware for particular applications, it's not going to be used everywhere. I tell deep learning or machine learning, it's obviously cannot be used in all the areas. On certain applications we might see design of certain hardwares in those designs using deep learning based, as I said, CNN on an FPGA, a lot of things there, right? So we might see applications and hardware using deep learning techniques which might make it more better, as I also said before, ML based techniques to optimize the circuit design itself for power performance and area. I had worked with Cadence, and there was a particular tool, and also I am sure companies like Mentor Graphics and also Synopsys will be having their own tools where their design, its tool itself, is going to have ML based techniques in order to have better performance optimization, better design optimization, better area optimization, lesser loss, so many things. As I said before, now people are focusing on coding in high levels, C or C++, and then it being transferred to RTL by the system rather than you coding in RTL. Obviously, RTL engineers are also there. I'm also talking about how lot of this high level design is picking up. Why? Because ML, people, the techniques, the systems is going to transfer this code in a high level, which is easier for us to code in, to an RTL based design, um, that is going to optimize in its own way and do it. And that also one area we might see a lot of improvements in, uh, as I said, ML based techniques to optimize the circuit itself, and materials, as I talked before, and other things I'm not entirely well equipped to talk about, and that's my limited knowledge about this area.
I know there is lot and lot of ways
One
in.
more thing, you had talked about neuromorphic computing. What do you think
Yeah,
about that? uh,
me.
yeah.
Yeah, when I think of neuromorphics, like, we are not completely demystified what brain is all about.
Yeah.
There is a lag in what computer architecture is seeing. You know,
Yeah.
it can be an issue of the transistor, because
Yeah.
transistors switching speed is in nanoseconds. But can
Yeah.
you really think of a human being trying to just make sure that his decision process is in the nanosecond, because we have hundreds and hundreds of process running in the backend, whether it's in the
Yeah.
frontal lobe, the parietal lobe, or the occipital lobe, working in full stack fashion, or the visual cortex just processing the visual aspects of what
True.
your neuron or system is getting its real-time feed from the eye. There is a
Yeah.
lot and lot of changes in which human physiology has not been experienced completely.
Yeah.
Li- Living all that, thinking of neuromorphic, we are on the verge of deploying something as a neuron. I
Yeah.
can give you a simple example of op-amp as a summer, which can really work as an neural network.
Yeah.
You just increase the number of resistor. It just keeps adding all those values. That's how your
Yeah.
synapses or the harbor is all about.
Hard.
I'll put the
Yeah.
picture and the
Yeah.
overlay and all. But what I feel is neuromorphic has not reached to an extent where it has that requirement of simulation software, which needs to be run on a specific kind of an hardware which is required for it.
Yeah.
Since we are on the verge of demystifying what human brain is, I think probably in another 10 to 15 years we will be intending to demystify what brain is. There is a scientist called as Susanna Arkelana Hollis,
Okay.
where her TEDx talks actually says on, she's actually known as a woman. She can, as an woman who can turn your brain into soup.
Okay.
Literally, she
Okay.
can remove all the cell matter and she can just have the neurons, and she can really count the number of brain cells which is there on a
Okay.
petri dish, kind of. But she gave an astounding statement in which, when humans started cooking food and started eating it, that's where the nutritional value came into the picture. And it
Yeah.
took us billions of years to come here. Whether
Yeah.
it can be Einstein thinking of something else, whether it can be Stephen
Yeah.
Hawking, even though he had the early stages of neurodegenerative diseases,
Diseases. Yeah.
ALS, yeah, that's the ALS.
Yeah.
But he was able to give such an astounding research which the world was shut down, kind of a research
Yeah.
where it gave a theory to the physics. It's when you just think of Stephen Hawking's books and all, there is lot and lot of things which is involved. But
Yeah.
even though he had the ALS, he was able to do an cutting edge research with those technologies which were available those days. When you
Yeah.
think of Werner von Braun, who literally launched the rocket, which was size of an elephant compared to
Yeah.
what is today, might be Starlink, everything which Tesla or the Elon Musk
Yeah.
thing. Probably today's technology is something huge, but never they had the technology, but they launched such a huge and hefty rocket to the moon.
Yeah.
It's that human potential which we are not completely demystified. So now
True.
I feel neuromorphic is one trend which can really give you job, one trend which can give you a research problem statement if you are doing your PhD or something. But
Yeah.
unless and until you experience something called as intelligence, you can never build
True.
what is intelligence on other system also. Because when I
True.
look at you, you are much more verbally sound, and you are much more feasible in terms of the knowledge because you have that experience. Now
True.
your experience can't be experienced by me.
True.
Then how
It's
can I
unique.
then how can I think of a machine which I just built from group of engineers whom I really don't even care about
Yeah.
tomorrow, whether it's 100 million engineers working on one hardware, whether it's one engineer working on one hardware? How can I intend to make that machine? Even when you think of Gary Kasparov actually told that, when we
Yeah.
are thinking of humans, we are not supposed to work as in humans. When you look at
Yeah.
some guy who has a six pack, you feel like, okay, I should have the six pack. When you see a
Yeah.
fat guy who is much more brilliant in his field, you feel that you should have been intelligent. Can you have both
Yeah.
six pack and the brain of that fat guy in simultaneous way? Because for six pack, you need to do diet and you need to do the workout. And
Yeah.
for the memory, you need to sit on your ass and you need to start working.
Yeah.
So because that's the
Correct.
key. That's the key. When people say that he is an prodigy or something, I don't care about it, because whether you're a prodigy or something, you are solving for your bill. It's not for my.
Yeah.
You are supposed to pay your bill. But
True.
tomorrow, as you told, power, process, and area, I have this thing called as power, process, and experience. I
Okay.
generally give it in all my machine learning and deep learning workshops. I give this power, process, and experience, whether the area comes in. Because you told about Moore's law, there is something called as Dennard's law out there. Dennard's
Yeah.
law is something huge today. You can't really demystify what he was thinking at that process. Dennard's law of scalability just said that there is going to be a massive increase in the area of the transistors, blah, blah, blah. But where are we still? We are not even
True.
in the verge of actually declining what Moore said. We are not even at the verge of what Dennard said. So
Yeah.
now, when I look at all these, I think there is a lack of experience that we have about what intelligence is all about
True.
and what the process is also all about. When you talk to a virologist will speak in a different terms. When you talk with a genomics guy, he will diagnose in a
So,
different way. When you
yeah.
speak about with somebody like, okay, I'll give you an example of a pediatrician, his approaches are different.
True.
So now there can be nowhere that things like brain can be simulated on a human like brain of a human
Brain
can be simulated.
simulated on a computer. Yeah.
Yeah,
It's not possible.
it's possible one day, but we are lacking with that experience.
Yeah.
Because that's what, right? When Yanli Khan came with the CNN, he was supposed to demystify what the visual process was.
Yeah.
So in a similar fashion, I think probably it's going to be research statement to hundreds of people who are trying to demystify what is brain, and and a problem statement to the hardware people also.
Yeah.
I think neuromorphic is going to be one trend one day, but I think let's just first demystify brain and then try to simulate a
Then
brain on
yeah,
a
I will be
computer.
talking about that if we question about AGI systems. I think
I have
when we talk
a
about
question on AGI.
yeah, I had watched a lecture. I think I sent the link to you. I don't know if you watched it or not.
I'll link it in the
Yeah.
description. I'll link it in the description.
Yeah.
Only I talk more. No, no, yeah, we are in a correct span. Sorry for it.
Fine. Fine.
I'll
It's fine.
edit. Don't worry.
Yeah.
Okay, fine. Thank you for asking me that question.
Yeah, I wanted to hear your opinion on that because you're someone who knows more about that than me. So I wanted to hear your opinion about neuromorphic computing, about how it
Yeah,
might
I think
go in the
was I
future.
was I good?
Yeah, you're very good. You're very good.
Thank you so much,
You're good.
brother. Okay, now coming back to your podcast with in my channel. Thanks for asking that question in my podcast.
It's fine. It's fine. It has to be. We need to
Something
learn from each
mutual.
other.
Yeah,
Yeah,
yeah.
something mutual.
No, there is a lot of ways in which theories have been different. I think you actually answered this question, but I want some more insights on this. There is a lot of difference between theory and the practical approach which you give for a problem statement. Whether you
Yeah,
solve the problem statement 100 times, you can really fail in the 101st
next.
time.
Absolutely.
Next time you
Yeah.
can really fail it because human experience is in such a way. I just want to you to answer this one question where whether this theory and the practical have a huge impact on how the job and the process of implementing something on a technology is. And I also want you to give whether this experience is good enough to just solve a problem statement in ML.
Which experience you're talking about?
Experience of solving huge problem statements in ML. Just like how I might be working on genomics data one day, but if I get a new genomics data, is it really enough to just solve that problem statement with that experience that we got from the previous data? That's what I'm talking about.
Talking about that genomic question, I'll just address that. We already genome sequencing of the coronavirus, which was done in quite a quick time when you compare it to the genome sequence which is done for the other viruses back 5-10 years ago. I think the genome sequencing of the coronavirus was done within a month. Thanks. Why we were able to do it so quickly? It was because we had experience of dealing with viruses, genome sequencing of viruses before. Experience surely helps. If imagine this situation, if coronavirus was the first such virus, I mean to say there was no other pandemic before, imagine nothing had happened in the past 200 300 years, and if this was the first such virus we were hit with, imagine the kind of problems that we had to face. Imagine there was no concept of vaccines and we had to start from zero. I think then, I mean, it would have been a new kind of problem that we had to tackle. It would have taken years of time. It would have been such, there would be such a disorderness in the society. But the experience of dealing with such things before has really helped us in order to solve this particular problem of genome sequence in the coronavirus so that they could go about researching about what can be done to develop the vaccine. Talking about theory and the practicals, uh, for sure there is a huge difference. That's why you're trained in a company when you join as a fresher. If you knew everything what they were doing, you could just be directly put onto a project the day you enter the company, but that's not it, right? You're going to be trained in things, even subjects you have already studied before in engineering. You'll be dealing with more hands-on. uh, I mean, there's a difference, right? You learn about embedded systems practical. You learn about coding, writing on a piece of paper. You never know whether that's going to work on a computer or not unless you go and write the program and implement it, right? You will never know the hardware limitations that is going to come unless you're going to do a project on hardware. You never know. I mean, I talked about an example about data science, right? Regression. You can just take any two data which are not even related and implement the regression algorithm and get some line which would say there is this is related to that. But if you do not have the domain knowledge, if you might be doing the wrong thing. So there's so many problems, various industries, without actually knowing what you're working with, without actually having the practical experience. It's really tough. The design methodologies, again, talking about VLSI, if you knowing how to, I'm talking about PCB design. Let's talk about PCB design. I think people would have used OrCAD, the layout, and all of that. Joining that,
Even
it's a tough
Tina is
thing.
also there.
Yeah.
Texas Instrument network analysis tool.
And connecting that, and also if you had used Cadence Virtuoso for building the analog circuits, in the end you need to connect everything. uh, it's not easy unless you have experience. If you have experience, it's going to come to you quite easily. If you do not have that experience, it's going to feel hard at the beginning. So a lot of things with experience, it's again coming to the brain. With experience, you're going to what is experience? Doing the thing over and over again. So your brain is used to doing that particular task. It is able to identify what you need to do to able to solve that problem. So with experience, you're going to solve a problem much quicker, much easier than a person who has not had any experience in practicals. So the labs we do in engineering is totally we're going to follow a lab manual, we're going to do it, and we're just going to implement what is given in the book. But practical experience is not that. You'd be starting off with just the problem statement. There's nothing else, no lab manual for you to solve a problem. You're going to be solving a new problem in a company, and there's no lab manual, nothing to reference on. You're just starting from ground zero, and it's really really tough. Imagine the people, I gave you example of genome sequencing, people who had to sequence the genome for the first time, how hard it would have been. People who suppose working on neural networks, the first neural network ever built. I don't know the history, but it would have been hard, right? Understanding about the brain, how people had to come across, how much years of experience, how much years of research they had to do to understand how brain works, or in particular area of brain works, if have to be more precise. We do not know how entirely the brain works. Some particular area of brain works, how memory works, and so on. Every area you consider, it's years of experience that counts, of how well you are in that particular field. Uh, Practicals is hugely different from theory. It's I think quite self-evident. Any person in the industry, you talk to him or talk to her, they are going to say the same thing. Even in management, I'm not. Let's leave technology. Let's leave science. People, managing people. Uh, all of that as well, it comes with experience. You cannot be put. That's why you do not get a management position as soon as you join as a fresher. You need to be trained. Every aspect of company or industry or research, it needs experience to actually know, to actually be good at it. You learn management, you study book theory, but in the end you need to be facing people. Then it's going to be a different ball game. So if you are not having that experience, theory is not going to help you there. That's why talking to people, talking like you're doing this podcast, so that other peoples can know how it is out there in the real world, and us also. We are nowhere near the expert. We are nowhere experts, right, in any of the field that we know. We need to talk, we need to learn, we need to see podcasts, other podcasts, we need to see YouTube lectures, so on and so forth. That is how we going to build ourselves as a person in any particular field that we're interested in, and that is how we're going to improve ourselves. Textbook knowledge is different and practical knowledge is different.
Yeah,
Every
I
day is a
know.
learning experience, according to me. Whatever you do in every aspect of life, your personal life and your career experience, with experience you'll know what to do and what not to do. It applies to everything.
Yeah, it actually is different, obviously. When you put your hands dirty, that's where you get the
Yeah,
real value of everything.
true.
Oh, we have come a long way with the ML now. Hardware is
Yeah.
also on the verge of it. But do you really feel so that hardware is sturdy enough or rigid enough to just do the computation for the present algorithms which we are building? Or
um
is there any requirement really required for this kind of an
the
algorithm?
latency and the memory access time, I think, is going to be a huge limitation. And I think more research has to go. We talked about Moore's law, how the number of transistors on a chip has been doubling every decade. uh, Memory access time has not been going the same speed. Memory access time is required for the hardware, right? You need to read data. The hardware has to perform, the algorithm. It needs to use the data to implement that. And if the data itself is not coming as quick as we want it to be, then there's going to be latencies. That thing which I talked about, latency and hardware resource utilization, it's that is the limitation that we really have right now. So it's not really sturdy enough. With that in mind, with those limitations in mind, we have been able to implement various algorithms on a hardware platform. But it's only going to get better, is what I can say. It is only going to get better. It is going
Yeah.
to get better and better.
Yeah, that's true because we have seen it. Not because
Yeah,
NVIDIA gave the GPU or else
yeah.
their Tegra processor. There is a lot involved. Architecture is
Talk about
involved.
TPUs. Even talk
Yeah,
about
Google
TPUs right
TPUs
now.
also, right? Yeah.
Yeah, absolutely. You don't even need a computer with a lot of. gigabytes of RAM to train. You have cloud platforms. You can
Even
train
Edge
your
also
algorithm.
is in the verge of its new market shares now.
Yeah.
Edge computing. There is a lot of answers which we are supposed to build, right? But there is something called as team which comes in. It's not me
True.
every time. It's not me every time. It's not I
It's not.
every time.
It's not
It's
us.
me or I, whether it's all about the team. That team
Team.
spirit is one thing that we have to really work on. How can you really adapt to that new workforce that you have put in all of the sudden? Whether I can, I think I can reframe you this question saying that how to build a proper team in order to get the things solved and also how to adapt in a team.
Um, team. When you talk about teams, first thing is when you're setting up a team, you need to be aware of for what you're setting up the team, for what objective you're setting up the team. I think that is decided by the project managers. I'm not sure about the management level, but yeah, when you set up a team, the team should be complementary in its skills. Everyone should not be having the same set of skills or the same set of uh, knowledge. It should be complementary. For example, if you want, I think you would have done the same thing. If you want to decide a team for your final year project, suppose you want to do a project, say on, say, I'm implementing a CNN on FPGA platform. Take that example, which I've already talked about. One guy should be good in understanding the hardware. Other guy should be good in to know what a neural network is, how we go about implementing it. Other guy must be good in programming, for example. So that's how you build a team, right? People who are complementary to one another. So if that is how a team should be built, if everyone had the same set of skills, it's going to be difficult to solve a problem. It's going to be difficult to solve the particular challenge that's in ahead of you. With multiple skills, with different backgrounds, that's how a company is built as well. No company has only people from yeah, just electronics or electrical engineering, people or from computer science, people from various backgrounds. I think that is very important because they bring in different perspectives. Team, one thing, as I said before, complementary skills should be there. The second thing is we talk about team spirit, right? How the team can gel together. That's also very important. If there is no proper communication between the team members, it's going to be very difficult. If you do not know what your team member is doing, you do not know what to do in the next step, what you want to do tomorrow. You might do something tomorrow and that guy might have already done it, or the guy might not be responding to your calls and you need to do everything by yourself. So there are various problems that comes into picture, right? So the proper communication is the first step in a team to function well. Each person needs to set up what this person is going to do, what that person is going to do, what I am going to do. So that is where communication plays a key role. And third thing is being open to one another. You should not be scared to tell a person whether it's doing right or wrong. There should be no ego clash between any two people. That is very important because ego. Somebody might say I'm not ego centric person or not, but that is not revealed until you come into that particular situation. You really need to be open minded to listen to suggestions. In talking about companies, right, you will be having people of different age, different educational backgrounds in a particular team. One guy might be from an IIT, one guy might be from a local college. That should not be a factor in determining that this guy should be superior to that guy. Again, ego should not be a problem. That can only happen if they are open minded and also can communicate with one another. And one more thing is time management. Each team member must be having to, they must be how do I put that word? They must be adhering to the time guidelines that have agreed to do, agreed to follow. If they are adhering to that, the team is going to function well. All these four things: communication, open mindedness, adhering to the things that have decided upon by setting deadlines or whatever. These three things are very important to determine how a team goes about doing well.
Yeah, I
Even you talk
know.
about startups, people in a startup, especially if you're starting a startup, the first important thing you need to do is how to solve a problem statement, which we have discussed before. And second thing is choosing the right members for your team. If these two things are not right, your startup is not going to do well. This is one example that I'm giving it applies to all areas as well. It's very, very important to follow those four things, as I said before, for a team to function really well.
Yes, yes. This is what teams really need to get in order to have that right workflow in their mind. Because if there is no proper team spirit, everything is going to
And also
shatter
one more
in
thing is willing to
seconds of
teach.
time.
You know,
Yes,
you might be more knowledgeable than your other members, but obviously you cannot do everything by yourself, right? That does not mean that you are angry at the other person who does not know much. You should be willing to teach him. You should be willing to help him, or willing to guide him. I'm not telling that you need to do whatever he does. At least willing to guide him, go in this direction, or look at these resources, or these are the resources. These are the websites that you can go and learn more about. Helping with team members. You cannot just do your part of the work and sit idly. I've done my part. Those people should do their part. You cannot sit idly. You should be willing to check up on others and help them if they're stuck. That's how team bonding is all about. Team bonding is again important. If that is not there, it's not going to work.
yes. Thanks for adding that point also, because
Yeah,
that's what actually needed to all of us. Sometimes we forget all these factors and we just go inside a company or a firm and people start showing ego problem. We will get hurt, obviously. And
yeah,
sometimes the work will not happen proper.
yeah.
So, last question. This just comes to the last question where what do you feel about the AGI which is being built and the present software architecture which is being used, whether it can be software or the hardware? What's your view on this AGI trend that we are really
Okay.
working behind?
Why this AGI is coming up is we have been talking about AI. I mean, not us, the whole world has been talking about AI for a long time now. Let's be honest. AI is not the new thing, it has already been there before. But why AGI is coming up is when you talk about the old AI based systems, it's mostly expert systems developed for one particular task, right? It cannot do another task. If you have developed an object detection system, it cannot do something else. If you have built a robot for doing one particular task, it cannot change its task in midway. Or I mean, let's give this example. If you have sent a robot to Mars, for example, and it you've built it for one particular application, and suddenly you want it to look at the environment and study about the environment as well, it cannot adapt or change itself immediately on spot. I mean, nothing is possible. Why I'm giving that example, I'll come back to AGI systems. We as humans, we are adaptable. We're adaptable to a lot of things. Um, I might be using my phone right now and talking to you. I'm not. I'm just telling you that. I might be texting or I might be watching a video and also talking to you. It's possible. You might be eating your food and watching TV. It's all possible. But when talking about AI-based systems, it's mostly limited to one particular task. Um, so that's why AGI is coming into picture right now. Old AI systems are mostly into pattern recognition, recognizing patterns. But now we're talking about AGI, we're talking about intelligence, adapting. I mean, you might have come across if you have trained a neural network for object detection, it might detect some things which are not even related to the thing you want to detect. As, for example, there's a funny image, there's a cat putting its
Adversarial.
face, yeah, there's a cat putting its face into boots, and the the object detection algorithm detects it as a polar bear, which is not even true, because it sees the cat's back behind as being wheatish, and it thinks it as a polar bear. There are a lot of problems. For example, if I show you a picture of a train track with a bit of fog and some bit of lights, you can directly tell that's a train track and there's a train coming in. But with that picture, it will be tough for ML based systems to identify that, because it's not a clear picture. So we are talking about intelligence here. So how can we go in this particular direction is understanding our brain, as I said before. With more insights about how our brain functions, we'll be able to create this intelligent based system. That's how neural networks are, right? Basically, it's trying to mimic. I'll give you this example. How I think you have you heard of the Hubel and Wiesel experiment?
Yes.
It was basically what they did was they placed electrodes in the brain of a cat and showed it images, And in one particular scenario, when the light was at a 45-degree angle, there was a sound. They had placed electrode in such a way that whenever that particular neuron spiked, there was a sound. So the external stimulus was making that sound, that neuron to go pop. So why is that? Why I'm coming to this picture is, so how the image works is, there is neuron. I forgot its name. It's called LGN. I just remember the short form of that. And there is one more neuron at the back. It is connected in a way that the neural network is connected. That is connected in a way in which the neural network is connected. So that was the basis of how the neural network was formed. But the thing is, how a brain, each area of the brain, as you know, is for different functionalities. And the most fascinating thing is, if you connect the nerves coming from your hand to the part of the brain which was working for vision, your brain is adapted. Your brain adapts it. Your brain adapts to each part of the brain, although it was designed initially for specific functionalities. It can adapt itself to other functionalities as well. That is not possible in the current neural networks we have right now. It is not able to adapt. That one thing I think which we will be seeing more and more, with more insights about how the brain functions. We might be seeing more improvements in the area of AGI. I think the closest thing that we have right now is the reinforcement learning, which I think is the closest thing that we have to a brain, because you have an agent, there is an environment, and there is an observation. That's how it works, right? Do you know about reinforcement learning?
Yes,
uh,
yes.
that's the closest thing, because what a human is, as a baby, it learns from experiences, it learns from observation, it learns from, when a baby does not know what is hot, what is hot, what is cold, does not know what is sharp, what is not sharp. It touches it, it touches and feels it. Oh, this is wrong, I should not touch it. This is okay, I can touch that. Oh, this is dangerous. Oh, this is not dangerous. That's how it learns. In the same way, when you have a system which can do that, suppose in the future we build a system, you place it in a random place, it can learn about the environment by itself. Won't that be wonderful? And suppose you place a car, you have a car, and there is an AI system built in which is not functioning right now, just learning the experience of how the driver is going about driving the car. After, say, when it is and it feels it's enough, it'll say, okay, the car need not to be driven by a driver now, I will start driving. That is basically reinforcement learning. It learns from experience, and there is no supervisor. All the ML algorithms you talk about, you have, yes, there is supervised learning, there is unsupervised learning. Unsupervised learning, again, it's basically clustering in the basic sense. I'm going to talk about supervisor. There's nobody to train, it trains by itself. When we come to that stage, reinforcement learning is there, but there is a lot of limitations there, and people are implementing a lot of reinforcement learning technique now. I think there are wonderful videos of helicopter doing stunts, various stunts. I think you would have seen that. Reinforcement learning is the closest thing that we have to a brain, because it is based on reward system, which is basically our brain functions, dopamine, serotonin. I think you would know that. Um,
All these are
reinforcement learn.
just the chemical factors which are just
You
affecting the
basically
way we
do
think.
tasks which increase the dopamine and serotonin. You not do
Rewards.
tasks, you tend to do tasks which will increase your dopamine and serotonin level. In the same way, you build a reward for an AI system. This is a reward. Basically, in the end, it needs to achieve a particular task. If it is able to do that task well, that is a reward for it, right? So if it learns by itself without any supervisor, I think we're going to see a lot of great things in the future for AGI systems. I think the most important thing, as I said before, understanding our brain functions, because intelligence is something that we are not able to quantify in any way. What is intelligence is something that we have not been able to answer uh, quite quite um, what I would say, in a clear picture. We have not been able to answer what is intelligence. I think the more and more we're going to understand about that, we're going to build AGI systems better in the future.
Yeah, Dheeraj, thank you so much for that answer because I just want to end this podcast with this one question. What can AGI answer tomorrow?
Uh,
What are the questions that an AGI can answer tomorrow?
okay, that's a big question because okay, the first thing I think is more and more adaptive systems might come into picture in the future. We might see with AGI robotics. I think iRobot movie, if people have watched, I think that might be possible in a way. I'm not in the structure of the body. I mean, it might be able to AI system might be able to do multiple tasks with or with a level of intelligence which not seen before in other AI systems. And also, I talked about natural sciences, answering questions about how the brain works. Again, that might be good. You might be able to get even more clearer picture when you're trying to build a system. You might understand, oh, this is how it works, and then you might get an idea of, oh, this might be how our brain works in a different way. Obviously, we're building AGI from getting inspired from by the brain, but when you're building AGI system, you might get an idea which might help you understanding the brain even more further, is what I personally feel. And I think space exploration, where you can now have rovers which are smart, which can do the task. You don't need to send humans to other planets, risk human life to send to other planets. You can send drones, you can send rovers, and understand more about other planets. I think that is going to be amazing. Now again, send these rockets to planets beyond the I mean beyond Jupiter, I mean the edge of the solar system, and get data from there. I don't think we'll be able to go further beyond that because
No,
we'll not be able
Voyager
to
1 and
communicate.
Voyager 2 have already gone there.
We can go
The
further beyond that,
satellites.
but when I'm talking about data, it'll be tough to communicate with them right after that. That's the problem, and the more major problem there. I think with AGI, there is no limitations. I think all field healthcare, again, biomedical and healthcare. I think we're going to see a lot more applications there. Um, Probably predicting the next pandemic, predicting what might be the next major disease that might going to come across, understanding more about viruses, things which causes problem to the society. I think AGIM will help us a lot there, especially with the computational power that is increasing day by day. Uh, let's see how it's going to function in the future. I mean, quantum computing, I am really interested in AI system built upon a quantum computer. I don't know whether that's actually feasible now. Is it? I'm not sure. Is it
No, we are
feasible,
on the verge
Vishwas?
of getting it. We are on the verge of getting it.
Have you read anything?
We are on the,
You're on the
yeah,
verge of
like
getting.
we are verge of getting it. There are see the Google came out with the supremacy, quantum supremacy, which was never being thought
Yeah,
by any person, even because that was a new theory altogether. Because they use the same principles. You can also
yeah.
think of something called as an Higgs particle. Sorry, there are a lot. In quantum there is lot.
Higgs
These are
boson. Yeah,
just
yeah.
these are just physical observations, mathematical predictions, chemical experiments, and
True.
actually the actual experience of what nature can be has been quantized in quantum computing. It's not been completely
Yeah,
encoded or actually completely decoded about what the mysteries of the nature is. I and you are communicating, but they
yeah,
they say there is something called as a parallel world, which can be an exact replica of it in a negated version of it. There are a lot of things.
yeah. There's
People have
a lot of things.
also,
Yeah.
in QSkit there is an option where you can really go to the QSkit, predict the number which you are thinking in your brain.
Okay.
And there is a theory in a quantum computing where if you predict that number right, it will not work. Kind of.
Observation.
It's,
You're breaking the
yeah.
wave function. Yeah.
Yes, there is
Collapsing the wave
lot
function.
and
Yeah.
lot of things which have been never been addressed. I think quantum can address, but it takes some time for it. But my research is on computational neuroscience. So computational neuroscience can make sense because we are not trying to build a computer on a chip, but we are trying to understand it. So that's where my 40 comes into the picture. Yeah, Dheeraj, it was very nice
Yeah,
talking
I
to
mean,
you.
I think the immediate implications of AGI is going to be in the everyday applications. Is that we need to accept that, right? Uh, be, from all the simple applications, your household, IoT, and sensors, everything automated. Probably we are not far away from having our own Jarvis at home, our own home,
Our assistant, virtual assistant.
our assistant, virtual assistant. Yeah,
Yeah, I think Dheeraj, I think we can conclude the podcast. I think if we just keep talking, it will be like 12-hour podcast.
Feller podcast. Yeah,
I think probably till now, morning 6, we can just keep talking and we'll never end also, kind of.
yeah, absolutely. We can talk about a lot of other things. You know how
Yeah,
technology
I think,
is
yeah,
kind of a boon and a bane at the same time. How it has made people more and more uh, more and more adapt to shallow work rather than deep work. How we are not utilizing our potential the right way, and how we have been lazy, becoming lazy. In fact, how people can be utilizing the time in a much better way, doing the task in a much better way. I think a lot of things people used to do in older times you're not able to do. Older times, I mean, just to say 20, 30 years ago, we have a lot of distractions. I think that is also affecting the work, that is also affecting lives of people. I think that is one more area where technology can also see how technology can be made. One more area of research, how technology affects people.
people's
I
life every
think
day.
there are a lot of negative things also. Yeah, there is a slight delay. There is my internet connection is quite poor.
Yeah, yeah.
I think, yeah,
Fine.
there's so many things. Time management also, one more thing which we are falling behind, especially in this age of distraction. I think many people find that as a huge problem to solve for themselves. So technology has also been kind of a bane rather than boon. With Google, with all of this AI, you don't need to walk, you don't need to go and switch on the lights. Even that part of your life also goes away, and your physical work is going to reduce. There are a lot of things, but in the end it's all up to you to become or be better, right? You should not let that affect you. In the end, we are the creators of technology. We should not be enslaved by technology is what I personally feel. But it's tough, it's really tough.
Thank you, Dheeraj, for this concluding note on what this
Yeah,
technology is. Probably next time, if I get a chance, I'll do part two with you. Like we will get a time, that's for sure. We'll make
yeah.
some time and do a part two on what this technology is all about. And thank you, Dheeraj, for this amazing podcast.
Thank you, Vishwas. Thank you so much. It was really, really fun to interact with you, talk to you. And I also had certain things which I felt you would know more. That's why I asked you some questions. I don't think that you're going to feel bad about that. I think
No, no,
it was
no.
nice for me to listen your opinions on certain things as well. It's nice to learn from different people. It was really, really nice to interact with you. And I really hope you have a really good remainder of the day, and wish you all the best for your future endeavors.
Thank you so much, Dheeraj. Thank you so